Hello all, I am Saurabh Parmar. I am a master's student in Computer Science Department in University of Florida. Today I will be presenting on the topic email spam filter using pattern recognition technique. This is a list of tools and packages that I have used. Development is done using Python in Ubuntu and packages NumPy, Skippy and Pandas are used. Package installation instruction is provided. You can use this to set up the environment. Let us understand why do we need spam filter, but first let us have a brief overview of what is spam. Spam email is a form of commercial advertising which is economically viable. Because email is very cost-effective medium for the sender, so spam is simply speaking any unsolicited commercial email sent in bulk. Spam can be harmless like unwanted product advertisement or can be a source medium for phishing attack, virus and scams. In phishing attack, spammer fraud user to enter their personal information on fake website using forged email to look like they are from banks or other financial organization. Let us now discuss cost of spam. Spam impact end users and corporates equally. There is infrastructure cost associated with spam. 50% of total email traffic is spam. Therefore, it increases unnecessary load on server and other communication channels. The productivity of individual decreases as they have to filter ham email from email boxes which can have many spam emails. It has been established that carbon footprint of spam email is equivalent to 3 million cars. Thus, spam email impact environment dearly. Other than this, there are security threats associated which I have already discussed earlier. Considering the associated threat, it is highly imperative that an efficient spam filter is required to counter the challenges caused by spam email. This is the global spam rate map that represents the rate of spam based on the regions. As you can see, the Asian countries and African countries have high spam rate as compared to others. In this project, content-based and supervised spam filtering approach is used. Content-based implies that the decision if email is ham or spam is based on content of email. Example, email having words like lottery, offer is more likely to be a spam email. Supervised learning is an approach in which a model is prepared from training dataset having a known label. The model predicate prepared is later used for prediction. The following 4 algorithms have been implemented in this project: naive k-nearest neighbor, support vector machine and random forest. As discussed earlier, this is a pictorial representation of the supervised learning model. Here, the machine learning algorithm learn from input features and label and makes a classifier model which is later used to predict the input. The input used in training and testing phase for this project is taken from the UCI spam-based dataset. In this dataset, there are total 4601 data points that have been correctly labeled as spam or ham. It contains pre-processed email and total of 58 continuous attributes. Last attribute of each email is label indicating if it is a spam or not. The performance of the implemented algorithm is evaluated on the basis of these 4 following metrics. They are accuracy, execution time, false positive and false negative. Accuracy implies the percentage of correct predicted labels in a test dataset. Execution time is the running time of the algorithm. False positive indicates the percentage of spam email that have been wrongly classified as ham by the classifier. False negative is the percentage of ham email that have been wrongly classified as spam by the classifier. False negative is a very important criteria to evaluate spam filter because even if one correct ham email is marked as spam by the classifier, the end user can lose an important email. Therefore, from an effective spam filter perspective, high accuracy, low execution time, low false positive and very less false negative is desired. Let us now proceed further and discuss regarding the implementation. Naive is the first algorithm that I have implemented. Naive belongs to a family of probabilistic classifiers that are based on Bayes' theorem. The naive assumption assumed is that pair of features are independent and do not affect each other. This is the formula for the naive and here PSF indicates the probability that the email is spam given that it contains a feature F. Now let us discuss more about the implementation. A span-based dataset is continuous and in this project it is assumed that it follows a Gaussian distribution. Therefore, to calculate probability distribution of feature given a class, Gaussian distribution function is used, that is shown here in the first equation. Therefore, in training phase, a classifier is created using Gaussian distributed assumption. Variance in mean of attributes given a class is calculated. In testing phase, probability that feature is present in class C is calculated. Since independence among features is assumed, overall probability is a simple multiplication. Now to predict the value, the class which result in maximum probability is assigned to the test data. Suppose if probability that C is span is greater than probability that C is hand, then the label of this test data point is span. Following are the results that have been achieved using our algorithm. The execution time is 1.5 seconds, the accuracy is very low, 81%, false positive rate is also very high, and false negative is fairly low as compared to false positive. Now let us discuss the next algorithm, that is support vector machines. These are again supervised learning algorithm. In SVM, we try to find a hyperplane that separates data point into two mutually exclusive regions. Consider a two-dimensional case. In this case, hyperplane is simply a line as shown in the figure. If for a three-dimensional case, it is a plane, and so on. There are infinite choices for hyperplane when data is linearly separable. In support vector machine, we choose optimal hyperplane that maximizes the margin. Margin is twice the largest minimum distance from hyperplane to training data point. In general, equation of hyperplane is given as fx is equal to beta plus omega tx, where omega is the weight vector, beta is the bias, psi is the training data set closest to hyperplane, which results in margin as 2 by beta. Therefore, to maximize the margin, we should minimize beta, provided the constraint yi omega tzi plus beta is greater than or equal to 1 holds. We can use Lagrange multiplier to solve and obtain weight and bias for this optimal hyperplane. Now the cases arise that dataset may not be linearly separable. In this case, support vector machine introduces a concept of soft margin. Soft margin implies that the hyperplane must separate most of the data point, if not all. Concept of slack variable and penalty parameter are introduced, and the equation based on slack variable and penalty variable is shown in the next page of this presentation. Here C is the penalty and epsilon is the slack variable. Now the scenario may arise that the kernel is not linear. In this case, the kernel uses a trick to transform input data into a higher dimension where it is linearly separable. And thereon we can use the same concept as we have discussed earlier. This pictorial representation represents the kernel transform. Here the input space data points are not linearly separable, but in the higher dimension they are linearly separable. This is the implementation that we have done for this project. We have used sklearn library for the implementation. We have implemented 3 kernels: RBF, linear and polynomial. In training phases, SVM classifier is trained using sklearn fit method. What CLF predict method does is based on the train and xtrain and ytrain, where ytrain is the label of the tested training data point. A model is generated. In the prediction phase, this model is used by CLF.predict for making the prediction of the label of the test data. As you can see, the accuracy is very high for all of the RBF, linear and polynomial kernel. Though execution time of RBF is high compared to that of linear and polynomial. RBF here stands for real bias and follows Gaussian distribution. Compared to naive bias, SVM performs exceedingly well. Next is random forest. It is the ensemble algorithm, that is, it is made from a group of many weak learners. For random forest, weak learner is decision tree. For creation of random forest, training data is divided into random smaller subset, and each subset creates a decision tree. This picture represents the working of decision tree. At each node, decision is made based on the feature of that node. like if money appear more than 3 times, email is spam, otherwise it is a ham. Random tree uses the same decision model. Input data is fed to all the decision tree and final classification is based on the majority vote. This is the implementation that we have done in this project. Again, we have used sklearn's library for the implementation. There is a method random forest classifier that takes the training data set and creates a forest, decision tree forest, the parameter based on the parameter that we have passed. The parameters are an estimator, that is the number of tree in the forest. By default, the value is set as 10. The minimum sample split required, the default value is 15, and the maximum depth, the default value is 5. The generated model in the class is thus required used in the testing phase to predict the labels using predict test features, which returns predicted labels. Now let us discuss about the results. As you can see from the graph, the results vary based on the number of decision tree. Here is the plot of accuracy versus the number of trees. The maximum is obtained when the number of decision tree in the random forest is 16. Parameters can be controlled and passed as command arguments. Accuracy is lowest when number of tree equal to 1. As in this case, random forest is simply a decision tree. The accuracy and execution time is comparable to support vector machine, and the false negative is less than SVM. So we can say that compared to SVM, it is better, and it's way better than naive-Bayes algorithm. Now let us discuss about the next implementation, k-nearest neighbor. K-nearest neighbor, it's a lazy algorithm and it's an instance-based algorithm. Instance-based implies that it uses test and train data instances to make decisions, and lazy implies that it defers classifier and model building till prediction time. In KNN, k-nearest neighbor of a test data point are found. The label of data point is then decided based on the majority. Example, in this picture, xq is negative, as out of the 5 neighbors, the 3 are labeled negative. Let us now discuss the implementation. To calculate the distance between the test data point and the training data point, I have used Euclidean distance. The formula is shown here. Here x and y are test and train data instances. Dataset is divided into test and training dataset based on 70-30 split. There is no training phase required because this is a lazy algorithm. During test phase, we find the Euclidean distance of test data point from all the training data points. Then we sort according to distances in non-decreasing order. Then we select the first k elements from the sorted list. These k elements are the k nearest neighbor for that particular test data point. Now the class of the test point is same as the class of the majority of its k neighbors. The test result accuracy and other vary with k. Here the graph of accuracy versus k is depicted. There is no certain trend, however accuracy is on average 82% and highest is attained when k is equal to 12. On average, these are the test results. This algorithm has running time that is more than 200 times of the rest and performs poorly on other parameters. Now let us conclude. The test result for all the algorithms are tabulated below. From this we can conclude that the random forest is the best classifier for the spam-based dataset because the accuracy of the random forest and SVM is comparable. However, due to smaller running time and less false negative random forest, it is the algorithm of choice. The naive-Bayes and KNN perform poorly. They both have accuracy of 81%, and for KNN the execution time is worse, that is 200 times more than the other. So the overall ranking for this dataset is random forest, support vector machine, naive-Bayes and k-nearest neighbor. The overall ranking here is just for the spam-based dataset. Your result may vary on different datasets. Now I will give you the demo of my implementation. These are the project files. The NB stand for naive-Bayes, random forest, SVM, KNN. Let me first run the KNN algorithm, as it will take the maximum amount of time. Here the dataset is read from spambase.better.csv data file. This is taken from the UCI repository. I'll show you the data points. This is a dataset in common CSV format. The last label here indicates whether the email is spam or not. The 1 indicates that it is spam, 0 indicates that it's a ham email. Now meanwhile, till the KNN runs, it will take almost 4 or 5 minutes for running KNN. I will show the running of other algorithms in new tab. Let's first discuss naive bias. As already shown in slide, the accuracy is 81%. 16% spam are classified as ham, 2% are classified as spam. This is false negative is 2%. The execution time is 1.493 seconds. In naive bias, what I have done is read the data that is from this spam-based dataset. I have created split into 2 parts based on the split ratio 0.3 into test dataset and training dataset. Now in get test result, what we have done is use the Gaussian model to calculate the mean and standard deviation, and then summarize the attributes for each class. This is done for the training phase. In the testing phase, using the already calculated attributes, we are finding the probability here. In testing phase, we are finding the probability, and this will return my class. It will contain the probability for class level 0 and class 1. Now in the evaluation phase, we check if the probability of 1 is higher, we will assign it to that class. If the probability of ham is higher, we will assign it to that class. In the evaluation phase, this will now return the test result. The test result is the predicted values. This test result will be used in evaluation phase. Now we will compare the predicted values with the original values, and if there is a match, we will just increment the count. So this will give us the accuracy. False positive is indicated when the spam is classified as email, that is when in actually the email was spam, and the test result resulted as a ham. So this is the algorithm that I implemented for the naive bias. Now let us see the next algorithm. Support vector machine. It will take almost 11 seconds. Here we have learned use the sklearn library for the implementation. It's still running. So as you can see here, for the RBI kernel, the accuracy is 93%, 44.19% are classified as ham, 2.49 is classified as spam. Total time taken is 8.08 seconds. Accuracy of all the three is fairly comparable, but the running time of the RBF kernel is higher than the other two. Here the open file just open the dataset and divided into test dataset and training dataset. Based on split ratio, which we split into 2 halves. This xtrain, ytrain, xtest, ytest. Xtrain and ytrain are used and fed into the used during the training phase, and they are fed into CLF fit method to generate the probability, generate the classifier model. The generated model is fed with X test values. Here predict X test, and this will return the predicted label list. So similarly, we can now calculate the accuracy, false positive and false negative. Here val is the predicted value, by test is the actual value. Actual email is spam and it has been labeled as ham, so it will get false positive. So this is implementation. These are the different kernels that I have selected. Kernel is decided by svm.svc. Here this is a linear kernel, and here I have selected polynomial kernel. Now let's now run the next algorithm. As you can see, the accuracy is 92%, 5.72% spam are classified as ham, 2.09% ham is classified as spam. The execution time is 1.54 seconds. We can pass the parameters here, like here I am specifying that the number of decision tree are 10. So in this case the accuracy is again 91%. It's a little lower, but yeah, it's satisfactory. Let's see what happens when the number of decision trees is just 1. The accuracy drops down to 83%. This is implementation. Here I have passed the command line argument. There are 3 arguments that are stored. They are the estimators. Estimator indicates the number of decision tree, a split ratio, and this is depth, maximum depth of the decision tree. Now I use SQL library, and I use random forest classifier to build the random forest from the training data set. Here the n estimators is equal to estimator that is passed from the command line argument, and similarly others are in the values. Now using predict method, we can get the predicted result, predicted labels for the test data set. Now we can just calculate the accuracy and spam and ham ratio as earlier. Here the output, if the output is spam, is ham, and it's actually a ham, it has been classified as false positive. If the output, the predicted value, is spam and actually was a ham, it is indicated as false negative. So this is all the implementation of the random forest. Now let us see if our KNN has finished or not. Yeah, it has finished. So as you can see here is that the accuracy is 80.79%, 10% email are classified as ham, 83.33 ham are falsely classified as spam. The execution time is 222.73 seconds. This is KNN implementation that I have used. Again, the spam based data set is the same. Split ratio is 0.3 seconds. Here there is no explicit training phase because this is lazy learning algorithm. Here I am getting k nearest neighbor based on the distance. The Euclidean distance is calculated here. Euclidean distance. This is Euclidean distance. We get a distance list and then sorted based on the key, that is distances. From the k values, we find the first k element in that distance list, and these are the neighbors. The neighbors are then used to find the label of the test data point. And this is where we are finding the class counter based on the label of the neighbors. Based on the class counter, we can predict like if it is a spam or a ham data point. We are just doing the sorting based on the class type, and the first value will indicate that it is just spam on him. So here similarly using predicted value, you calculate accuracy, false positive and false negative. So this is all about the implementation that has been done in this project. You can change the command line argument for this also, like I have done for default k is equal to 1. You can change it to k is equal to 3, 4, 5, 6, anything. It will reflect here. It will again take more than 5 seconds. So this is an implementation, total implementation. Now this is a list of references that I have used that has assisted me in this implementation. I would particularly recommend sklearn documentation. Thank you. If you have any queries, you can post it in the comment section.